All right, so congratulations. You've pretty much learned everything you need to know to perform 99% of your queries. Most of the time when you work at, like a social media company or any big tech company, you're not going to do any crazy fancy SQL unless you really need it. And most of the time, the SQL queries that you're going to pull are pretty simple. But the last 1%, most people do not remember their syntax, or they have to search for it. So for example, one of them is the window function. This is not super complex, but it's just that some people have to Google it every time just to remember what the syntax is. I'm still going to teach it, even if most of the time I don't really use it. I rarely use it. Maybe I use it once out of like 100 queries. Like I myself have to look at the documentation again for the syntax, but I do think it's important for you to know the existence of it so you know how to search for it, or you know that it does exist. So you can simplify your workflow. So all the lessons up to now, we usually perform operations at a single row, right? Like the where clause and stuff like that. You can't add or subtract value from one row to another different row, right? We couldn't do that. This is kind of where the window functions come in. They have a special syntax, as you can see. It might look kind of intimidating, but we'll break it down soon. So basically, I'll tell you what a window function does. It will perform aggregation calculations on a set of rows without collapsing them like aggregate functions. So if we remove all of this over partition by, order by, or whatever, then we get a normal aggregation function. And you know what that does. It takes all the rows, collapses it into one row, and it has like a summary, it has a metric. However, for window functions, the rows will be retained instead of aggregating them into a single row. The value of the window function is related to the previous rows. It might be a little bit confusing now, but once I show you an example, it'll make a lot more sense. And one of the common use case of window function is to calculate a cumulative sum, or like a rolling sum, or a running total. So first, let's talk about these two keywords. I'll just talk about it and then we'll go through the example. We have partition by. This is usually to group rows into partitions. And then we have order by, which defines the order or sequence of rows within each window. Let's look at this table. Sorry, that's a little bit small. I did want to include a lot of rows. So here we go. So this is the table that we have. We have a person ID, timestamp, and minutes meditated. So basically each row is a meditation session done by person 1, 2, or 3. So there are 3 people here. And then the timestamp tells you at what time they did it. Don't look at it too much. It's technically impossible, because imagine if these are milliseconds, then if they meditate for 20 minutes, then it's impossible that they meditate again in like the next second. But let's pretend these are minutes actually. Okay. So don't worry about the validity of this table, but just think about there's a timestamp, like to tell you when they started meditating, how many minutes they meditated, and which person did it. Now, if we added a column called aggregate minutes meditated, and the definition of this column is a window function where we sum the minutes meditated over order by timestamp. Then what that does is it's going to order by timestamp, and then it's going to start the rolling sum from this order. So as you can see, minutes meditated here is 10, and then the first timestamp that we have will have a value of aggregated minutes meditated for 10. So here we have 15, because if you add all of the minutes meditated, you get 10 plus 5, so you get 15 in total. And then you add 20, so that's why it's 35. And then you add 10, which is 45. You add 5, which is 50. So it's a rolling sum. All right. So why is this important? Well, sometimes in some databases, well, first of all, databases are usually really big, so you don't want to query it multiple times, right? And in this case, imagine if you want to quickly know the running sum at a specific point in time, like for example, at 6,000, at time 5,000, then you could know it right away. So that's a lot faster than redoing the query with different filters, with different where statements. Like for example, how long have I meditated on December 25th? Then you could see, okay, that's how long I have done it in total. And then what about November 12th? I don't always want to re-query the database with different filters. I want to answer these questions fast. So that's pretty useful. So now let's move on. As you can see, we didn't use the keyword partition. And in the next one, we do use partition by. So to motivate this, as you can see, The timestamps are in order, and then the aggregated minutes are combined. But it's not really useful because we're combining all the people together. What if I want to know for a specific person how many minutes they have meditated so far, right? Right now, they're combining all of them. So it doesn't really mean anything. I can say, yes, at timestamp 6,000, all three of them together have meditated 225 minutes so far. But usually people care about specific people. So if you want to care about specific people, then you use partition by. So as you can see here it's a little bit different. And you could see by the different colors that now it's partitioned by the person ID, because I have partitioned by the person ID. And then the running total actually starts the same way at timestamp 0, and it's going to start adding all the minutes meditated until it's a different person. Then we start back at 0, and then we do it again. And then we start back at 0 once we reach person 3, and we do it again. That way, we can finally answer the question at timestamp 8,000, how many minutes has person 1 meditated? Then here you can answer it, 110, 110. Back then, you couldn't do that, because if we looked at the old table, we looked at timestamp 8,000. First of all, there are multiple of them, and then it says 245, but that's not true, right? Person 1 did not meditate for 245 minutes because we are adding everyone else's minutes meditated. So now we have partitioned it. We're able to distinguish between person 1 and person 2, and then we're able to answer the question like, at this timestamp, how many minutes they have meditated. So that's pretty cool. So that's pretty much what partition by does, and then also what order by does. So what do you think happened if we do order by timestamp descending? Then what's going to happen is that instead of starting from 0, we're going to start from 9,000. And then aggregated minutes for this row would be 40, and then this row would be 60, and then 70, and then 75, because we're adding it that way now. Cool, awesome. So that's pretty much it for the syntax of windowing functions. Now, my favorite use case of using window functions is to create a Pareto chart. Pareto. So Pareto charts, basically what they tell you is they tell you the top X percent of customers, how much percent of the sales do they contribute to. So usually we care about, 80% or like 90%. We can understand the distributions of the users, right? Like, is it a long tail, meaning that all our revenue comes from like a few people, like sharks? That's how gambling works. If you go to a casino, most of the money that they make is through whales, like the top 10%. Like 90% of their revenue comes from the top 10% of their users, right? As opposed to maybe like a gym membership. Imagine if everyone's consistent, then 50% of the customers account for 50% of the sales, which is probably not true, but let's just assume that everyone is very consistent in their workouts. Okay, so as you can see in this chart, they have labeled this for us. So we know that 44% of the customers account for 95% of the sales. A lot of the times this is useful because it allows us to not focus on these people because it's so much work to keep these guys happy, but they only give 5% of the revenue. While these people, the top 44% of customers, these are the ones that we care about because they generate the most revenue anyways. So whenever you work for a social media company, it could be really important. Like you can ask questions like the top 10% of video creators, how many views do they account for, right? Kind of like YouTube also, there's like billions of videos, but most of them, they get like 0 views. So it's only like the top 10% of video creators that account for 99% of the views, right? Or you could think of it in advertising. How many top advertisers account for 90% of our revenue? Then you could use this chart. You could look at, so 90 is right here. And then if we go down, 33% of the top advertisers account for 9% of the revenue. So let's hop on mode to play with the window function. All right, so we have 3 questions that we can work on. So list the top 5 highest investments made by each company category code. Okay, so the table that we care about is this one, Crunchbase investments. Let's just do a refresher, see what the table looks like. The question is asking for each category code, like is it consulting, advertising, news, messaging, whatever, what is the highest investment ever made from an investor to a company, right? So for example, each time an investor gives like an amount of dollars, like $1 million to company Tokita Investments, then that's one transaction. So what were the highest transaction of each category? Okay. So first, how would you do that? Well, the hint is we care about for each company category code. So that will give you a hint. Okay, so we probably need to partition by the company category code. And then next is top 5 highest investments. Okay, so we probably care about investments. So that's what we want to order by. And then how do we get the investments? Well, we get raised amount. That's the investment dollar. All right, let's just try to list a few things that we care about, because this table is quite big. So let's just do company category code, which is what we care about. We care about the company name, and then we care about the investor's name, and then we also care about the raised amount. Let's just run this again so it's a little bit more clean. All right, so these are tables we care about. And now what we want to do, let's create a new row called, this is like the ranking, right? So what we can do is we don't really care about how, like we're not going to sum it. We're not going to average it, right? So remember we have many aggregate functions, sum, average. We're going to use count. All right. There's actually another way of doing this and I'll show you later, but I'll just count and then over partition by, because I care about the category code. Okay, did I spell it right? Yes, I did. Partition by, and then I want to order by the raised amount USD. So basically what I want to do is I want to sort them such that I get a ranking number. So if it's the highest transaction ever, then I want a 1 on it. And then if it's the second highest, I want 2. And then the third will be 3. So I want a ranking. So that's why I do count. And how do I want to count? I want to count by descending. So the highest one will be 1. And then later on, it'll be 2, 3, 4, 5. Wait, it'll be easier if I just show you. We'll call this as rank. Okay. So as you can see, right now, there's a bug because when we partition, they kind of think of like a null as like values, but I don't want that. And then the ranking, they'll continue to count. So we don't want that. So what we're going to do, also what we're going to do is we're going to order by company category code so that we can easily see. We're going to order by company category code and then also raised amount USD descending. Okay. Let's just run this again. Okay. So now they're bucketed by company code. And then if you see the raised amount, as you can see, there are a bunch of nulls. So what we're going to do is we're going to take those out. Raised amount USD is not null. So now you won't get any null anymore. So let's try to run this again. All right, excellent. So as you can see in here, what happens is you don't have any rank 1. And the reason why is because there are multiple of the same amount. So Bank of America and JMI Equity, they both invested $200 million to add knowledge. And so that's why you have 2 rank 2s. But I do want to know just top 5s, right? So I want one of them to be rank 1. So instead of count, what you can do is something called row number. So row number. So this is a special syntax. It's also one that's pretty useful. And then we run that. And now we get the actual ranking, 1, 2, 3, 4, 5. As you can see, the raised amount USD, it diminishes. And then these are all for advertising categories. If you go all the way down, let's see if, nope, still advertising. Okay, let's not limit these. Actually, let's limit this to something bigger. Limit 10,000. Let's see if they let us do that. Okay, cool. Yeah, so advertising. Let's do the next page. Oh, lots of advertising companies. Okay, still advertising. All right, there you go. I found the break. All right, so as you can see, we have all these advertising companies, and then how much money they raised. Well, 2,000. That's very little. But anyways, and then as you can see, once this is done, then we kind of reset the rank, and then now the company category code is analytics. Like Palantir Technology got a lot of funding, and now it starts at 1 again. 1, 2, 3, 4. So that's going to be pretty useful because we care about top 5 highest investments made by each company category code. All right, so we have this now, so good. So the only thing we need to do now is to filter by top 5, right? So how do we do that? Well, what we can do is we can just use this as a subquery, name it table or something, ranking table. And then we're gonna query this table that we just made. And then what we're gonna do is we're just gonna filter by rank is smaller or equal than 5. So I'll just do select from, and then we could actually do this so that's more clear. So select from this whole table where rank is smaller or equal than 5. Okay, we run this. Aha, there you go. So now we have every transaction, the top 5 transaction from each company category code. Advertising, 1, 2, 3, 4, 5. Analytics, automotive, yeah, biotech. Wow, this is a hotshot company. And then cruise sell, as you can see. All right, cool. So let's go to the next question. What is this running sum of orders in amount USD for each account ID? All right, so for this question, we have the orders table. Not much documentation here, so I'm not sure what kind of order it is, but we know that in the table, you have IDs for the transaction ID, I'm guessing, because each row has an amount USD to it, so I'm guessing these are transactions. And then the quantity of whatever they bought, and then the account ID, depending on which account it is. As you can see, there are different account IDs. Okay, so my question is, what is the running sum of orders in amount USD for each account ID? And then we want to sort that by occurred at. So same thing as like timestamp. Okay, so this is pretty simple because it's very similar to what we did for our example when we went to the slides. So what we want to do is we sum the amount USD over partition. What do we want to partition by? We care about for each account ID. So partition account ID. All right. And then what do we want to order by? We want to order by the date. So occurred at. Okay. So let's see if this works. Select it. Okay, syntax error at or near account ID. Oh, we forgot the word by, so don't forget that. Partition by. Oops, I forgot an R here. Okay, that's better. Run selected. Cool, awesome. So now, as you can see, it's ordered by the date properly. And then for each account ID, you could see the running sum. So for example, first we have $973 at this timestamp. And then cumulatively, 2 months later, it gained over $20,000. And then if we look far, then we changed. Did we change account IDs yet? No, we did not. So it keeps adding to the sum until there's a new account ID. Then here we start from the beginning again, and then we just have the running sum like this. All right, so then the next one is going to be our last one. We talk about the Pareto chart. And then what we want to do is we want to do the same thing here. What we care about is how many percent of the top accounts contribute to the percent of the revenue gained from this store. I'm guessing that account ID is the ID of the customer. And then what we want to know is for the top 10% of these customers, how much money do they bring in? What we can expect is a line chart that we saw previously. Okay, so first, how do we do that? So what we want to do is we want to group them first. We want to group them by account ID because we want them to be a single entity. We don't care about all the different transactions. We just care about what's the total amount of revenue that they brought in. So I am going to sum amount USD as total USD, aka the total amount of money that they brought to our company from tutorial.orders group by 1. Okay, let's see what this looks like for now. All right, so if we run it, as you can see, we have we have an account ID and then how much money they brought to us. So now what we need to do is to rank them. The reason why you want to rank them, because in the Pareto chart, you care about the top accounts. You care about the top customers. And if you care about the top customers, basically, let's go back to the chart real quick so I can explain it. So as you can see, the line increases at a very high rate and then it slowly decreases. And the reason why it does that, it's always going to be monotonically increasing, and the derivative is also monotonically decreasing. The reason why is because everyone here these are like the top customers. And then as we go further down the line, the customers are generating less and less revenue, which is why it gives this smooth line. So that's why we have to order it. Okay, how do we order this? Well, we learned about rankings, right? So what you want to do is you want to order them by the amount of money that they make. So that means rank 1 would be the top account ID. Okay, so how do we do that? So first, let's make this a subquery. Okay, call this table, let's just call it T. Call this T, and then we're gonna do some window function over it. So first we're gonna include all of the rows, just so that's easier. And then what I wanna do is I want to have a running sum, because the reason why we need that is because we need to know how much revenue they're bringing in. Okay, over order by total USD descending as, let's call it running sum. Okay, so we have that, and then the other thing we want is row number, because I care about their ranking. Row number over order by total USD descending, same thing as ranking. All right, let's see what this looks like. Oh wait, I should order it. Is it ranking? Oh, from this table, and then I want to order them by order by total USD descending. Let's see. So here's why I need these two things. So now that we have these two columns, I can say, okay, the top 1 customer made $382,000 for our company. The top 10 customers total together, they have made $3 million for us. That's why this is useful, right? And then we can say, the top 100 accounts made $15 million for us, right? So you're almost there, because now you have the rankings, like top 1, top 3, top 37. You could say things like the top 40 customers, they gave us $8,984,000 in revenue for us. But we want these to be percentages. Now, how do we do that? Well, first, you need the total sum. You need the actual total sum, and you also need the actual total number of accounts, right? So there's a little trick that I can show you. You don't really need to do it, because what you can do is you can literally just have a separate query where you sum all of the total USD together. That will give you the total. And then you could also count all the account IDs, and that will give you the total accounts. And then you could just divide these, like 1 divided by the total number of accounts, 2 divided by total amount of accounts, and also the running sum divided by the total revenue made. But I'm going to do something kind of quirky, I guess. So what I'm going to do is I'm going to do the same thing, but I'm not going to order by anything. And in this version of SQL, what that does is it just gives you the actual total sum, right? So if I run it, as you can see, as you can see, the total sum is the same for all of these rows. And that is because that is actually just the total sum of revenue from all of the accounts, from the whole table. So what we can do now is just divide this number by that number to know what percentage of the total revenue the top 1 account contributed to. And then we could do the same thing with ranking, actually. We can do, we could count this time. So we could count like account ID over something like this as total accounts. Okay, let's run this. Oopsies. There you go. So now I have the total accounts on the right hand side of ranking, and I have the total sum on the right hand side of running sum. Okay, so now we want the percentages. How do we do that? Well, let's use this as a subquery. So let's think of this as a new table. Let's call it F. Press tab on it so it's easy to read. Now, what I'm gonna do is I'm just going to get a column that is ranking divided by total accounts, and then another column which is running sum divided by total sum, so we get percentages. Okay, so let's do the ranking first. Select ranking. I'm gonna multiply that by 1.0 because we want float numbers, and then total accounts, right? So we're dividing ranking by total accounts as percent accounts, right? And then the other column I want is the running sum. Same thing, times 1.0 divided by total sum as percent revenue from this table. Okay, and then yeah, let's run this, see what we get. Aha, perfect. So as you can see, the percentage of account, this is one account. If we had one account, then technically it's 0.2% or 0.3% of the accounts, because we have 350 accounts and then one of them is basically 3%, the top 3% of the accounts. They represent 1.6% of the total revenue. And then it continues, it goes on, it keeps adding it. At the end, you're gonna get 100%, because 100% of the accounts, they contribute to 100% of the revenue, right? So what you can do now is you can add chart. You could use a line table to visualize this. So on the x-axis, we want the top accounts, and then on the y-axis, we care about the revenue. As you can see, now you have this beautiful line. So if you have questions like, okay, I wonder what the top 10% of the customers or the accounts, how much revenue do they give us? All right, so the top 10% amount to 34% of the revenue, which is not bad. It's this is actually quite a nice distribution, as in it's not like a monopoly where the top 10% accounts for like 90% of the revenue. So yeah, or you can do it the other way around too. You want to know, okay, so I want to know for 75% of the revenue, how many of the top accounts contributed that? So you just move your line, or you move your mouse all the way to here. Aha. So you know that, like, you can see the number on top of percent revenue. So percent revenue, I want this to be at 75. So now you know 34%, as you can see the number on top, 34% of the top accounts account for 75% of my revenue. All right, so that was fun. So that is pretty much it for window functions. As you can see, there are multiple applications of it. Not very common, because most of the time you might just do some simple join, simple filtering, simple aggregation. But if ever you need to do window functions, this is how you do it. All right, thank you so much, and I'll see you in the next one.